Up to now, we've treated our samples, x1, x2, x3, all the way up to xn, assuming that they arose as a result of some random experiment. The xi are drawn from some distribution with population mean mu and population variance sigma squared, and we use the sample mean x bar and the sample variance s squared as estimates of mu and sigma squared. In practice, the index I is typically going to be a time index. The xi's that we are observing are usually observed in sequence, and so the I tells us the order in which we observe the random variables. When that's the case, we say that the sample is a time series. Now, statistical process monitoring doesn't just apply to time series data, but it naturally finds a home within time series analysis. Because if the distribution from which these random measurements are taken changes over time due to some external factors, a war is declared, a pandemic outbreak, the results of an election, and so forth, or potentially internal factors, we decide to have a new addition to the manufacturing process past a certain time. A company decides to modify the manufacturing process after a certain date, or the government implements a policy change, and so forth, then it's conceivable that the sample mean and the sample variance will not be providing you with a useful summary of the situation anymore. Potentially the sample mean and the sample variance prior to the change in distribution and after the change in distribution could be useful quantities, but if you don't know when the change has occurred or whether the change will have had an effect on your measurements, then how do you decide what index to use as your cutoff point? Now, usually it is smart to plot the data in the order that it has been collected, assuming that you have a time index. Usually then the horizontal coordinate is going to be the time of collection. That could be the order in which the observations are measured, or potentially the actual date, the day of the week, the quarter, the year, and so forth, where the measurement was taken. And the vertical coordinate would be the actual value of the observation, the xt. When we're talking about time indices, usually we use the index t instead of I. If we talk about specific locations, we might use I instead of t. And you can imagine looking at the same type of thing. Like, do we have a different distribution for different locations, for instance? At any rate, you plot the data and then you look for trends, for cycles, for shifts in the behavior of the measurements. I have here 3 time series, and they record sales and $10,000 for 3 different products. We have the passage of time. For the first example, A, this is measured in years. For the last example, is measured in weeks. And for the middle example, B, it's also measured in years. But we have fraction of years. The question that you or the stakeholder or whomever manages the employees who sell these products have to ask yourselves is there any moment in these time series where we should take action and change our approach to how we sell these things? Now, if you just look at the numbers, it's not obvious that there should be something. I mean, perhaps some of you will notice that there seems to be a little bit of ups and downs and up and down and up and down and up and down. There's something there. And when you have small time series, it's like, oh, there seems to be a bit of a break here. We have large values, 9, 10s. Here we have 3s, 5s. Small time series, you might be able to spot what's happening just by looking at the data, but it's so much easier to do so when you plot the data. So let's plot the first time series. We get something that looks like this. And because there is a sequence, an order to the measurements, you might as well link the observations with a line, with segments. So we look at the sales here on a yearly basis. There are occasional drops in sales from one year to the next. I mean, and that's going to happen even if everything is going as swimmingly well as possible. Well, there might be years where you just don't have as many clients, or a big client has closed its doors and you just don't have a replacement client for it yet. All in all, even though there is some up and down in the sales, the trend is clear. Sales, on average, are going up. Now, if you show the full time series to your stakeholders, they will recognize that sales are going up. But if you only ever show them the last 2 data points, give them these figures, what they're going to see is a fairly drastic drop in sales. And they might think wrongly that some issue has arisen and changes have to be made. And this happens more often than you'd think. If you've had a good year here, and the next year has seen a drop, and this is all the information you have at your disposal, you think you need to do something. Punish bad employees. Make them take special selling strategy courses. Who knows what, right? 2 points don't really make a trend. If you look at the second time series, where we have quarterly data for about 4 years worth of data, sales data, there's a cyclic effect. It certainly seems as though there's a seasonal component to the sales. Perhaps this is a shop that sells, I don't know, windsurfing boards. You can imagine that there are seasons where you wouldn't sell as many boards. But there are patterns that repeat themselves. There seems to always be an increase from Q1 to Q2, Q1, Q2, Q3, Q4, except perhaps for this one. But in general, there's that increase. And there typically is going to be an increase from Q2 to Q3, with a few exceptions. You'll often see decreases from Q3 to Q4, or something like that, Q4 to Q1. But overall, there does seem to be an upward trend. Now, the cyclicity is not perfect here, and we're noticing it. Like, if this was a perfect cyclicity, that point should be up, but it isn't. Well, perhaps something happened here. It's a possibility. But whatever happened there, if something did happen, the system recovered. Again, if you only ever show the last 2 points, people might think something horrible is happening and it's time to change things. Finally, let's take a look at a time series in weeks. Clearly, after the 10th week, something happened. What happened? We don't know. The special causes that caused this gigantic drop and the presence of a new normal here as opposed to the old normal, but we don't know if it's internal or external. This is not info that we have at our disposal. But definitely, if you look at the patterns here and the patterns here, they are not the same height anymore. There's been a shift in the trend level. You'd look at this and you'd think to yourself, some action is probably needed here. Or at least we need to look into this further. Right? If you do not plot things sequentially here and you just take the sample mean, you might get a sample mean close to this value here. You just look at the mean, that looks like a decent mean. But you will miss the fact that after week 10, we have a completely different system at our disposal.